This video will cover the basic information related to anchor rod tightening on different structures within the Minnesota Department of Transportation. First, the various signal, lighting, and overhead sign structures and their differences will be discussed. Next, the various loads acting on anchor rods and the connection that is required to carry this load will be explained. Then, torque, tension, and their relationship to one another and importance in double nut moment connections will be described. Finally, this video will comment on loose anchor rods and their prevalence within Minnesota and the country. Within the Minnesota Department of Transportation, there are two main categories of structures that have foundations requiring anchor rod tightening. The first category of structures are signals and lighting. The signals and lighting category contains light poles and traffic control signal poles. Light poles can be stainless steel, galvanized steel, or aluminum. The light poles can either have single arms or twin arms, and can range in height from 30 feet to 50 feet. High-mast light towers are lighting units that are typically 100 to 120 feet in height, and often have a high light base design. Traffic control signal poles are identified as either PA poles or BA poles. PA poles consist of a transformer base, the vertical pole, a mast arm truss, and, if applicable, a luminaire shaft extension. PA poles are 21 feet in height, with mast arms that can range from 15 to 45 feet in length. BA poles consist of the vertical pole, a mast arm truss, and, if applicable, a luminaire extension shaft. Unlike PA poles, BA poles do not use a transformer base. The second category of structures is overhead signs. Overhead sign structures are large overhead directional and informational signs. They can either span a roadway, cantilever out over a roadway, or are mounted to bridges. Bridge-mounted overhead signs do not require foundations and anchor rod installation. The anchor rods used on structures within MnDOT range in diameter from 3/4 of an inch to 2.5 inches. Anchor bolt diameters are measured by quarter inches. Light poles use anchor rods that are 3/4 of an inch to 1.25 inch. Signal poles use anchor rods that are 1.5 inches to 2.25 inches, and high-mast light towers use anchor rods that are 2 inches in diameter. Overhead signs use anchor rods that are either 2.25 or 2.5 inches in diameter. Anchor rods are also specified by their type, either type A, B, or C, and their grade. Anchor rods must be properly installed in order to remain tightened after exposure to service loads. The structure type, shape, size, and attachments all affect the type and magnitude of loading that occurs. However, regardless of these factors, all structures will be exposed to long-term fatigue loading due to wind that anchor rods must be able to resist.
Anchor rod connections are a critical component of the foundation and the pole. They not only attach the pole to the foundation, but they play an essential role in safely transmitting the load from the pole to the foundation. When the nuts on the anchor rods are not properly tightened, loads will not be transferred as designed, reducing the fatigue life of the anchor rods and the service life of pole structure, potentially leading to a structural failure.
A double nut moment connection is used on MnDOT structures to resist loads. A double nut connection consists of two nuts, one above the base plate and one below the base plate. Washers separate the nuts from the base plates. The bottom nuts are often referred to as leveling nuts and allow contractors to easily level the base plate of the structure. When installing this type of connection, the leveling nuts are first installed onto the anchor rods, followed by the washers. Next, the structure's pole is installed. Finally, the remaining washers and nuts are installed on top of the pole base plate. The thickness of the base plate, together with the washers, creates what is referred to as the grip length. This thickness is the distance that the top and bottom nuts are gripping together. The range of base plates in MnDOT for light structures is 3/8 of an inch to 1 inch. High-mast light towers have grip lengths of 2 inches. Signals have base plate thicknesses of either 1.25 inches, 2 inches, or 3 inches, and overhead signs have base plate thicknesses of 2 inches. The base plate thickness and overall grip length affects the performance of the double nut moment connection. When installing structures, contractors apply a torque to the top nut of the double nut moment connection, either through the use of a torque wrench, hydraulic wrench, or open-end wrench. When torque is applied to the nut, an axial force develops within the anchor rod. Connections with properly pre-tensioned anchor rods have a smaller chance of nuts becoming loose under service loads. Torque, although a quantitative measure, cannot adequately ensure pre-tension, although pre-tension is the sole way to check tension post-tightening. Torque and tension are related with the below equation, T equals KFD. In this equation, T is the applied torque. F is the pre-tension in the fastener. D is the anchor rod diameter, and K is the nut factor. K encompasses those things that might affect friction between the anchor rods and nuts. Shown is a graph relating the torque applied to an anchor rod to the pre-tension the anchor is experiencing. This graph is from an anchor rod that was tightened on a Type 5 overhead signpost with 12 2.5-inch grade 55 anchor rods and a 2-inch base plate. As shown, as the torque applied increased, the pre-tension that the anchor rod experienced also increased linearly. This anchor rod was fully tightened when it reached 60% of its yield strength of 55 ksi, shown by the dotted orange line. Anchor rods are tightened in 2 distinct phases. First, the anchor rod is tightened until reaching snug tight. Snug tight occurs when firm contact is made between the nuts, washers, and the base plate. At this phase, the anchor rod elongates linearly. Snug tight is approximately 10% of the yield stress of an anchor rod. The second phase of tightening requires the nut on the anchor rod to be rotated a specific amount. The rotation angle specified correlates to a pre-tension added to the anchor rod past the snug-tight condition. Completing the specified turn of nut should get the anchor rod to the final pre-tension value required. If the anchor rod does not reach the sufficient snug-tight value in the first phase of tightening, the bolt will not be properly tightened in the second phase. If the anchor rod is over-tightened, it could lead to yielding. However, if the anchor rod is under-tightened, it will not reach the full pre-tension value, and the nut could easily become loose.
I've inspected the better part of 50 overhead sign structures in the metro area and have seen firsthand the challenge of assessing just how tight the nuts truly are.
In 2014, MnDOT Metro Inspector found that 30 to 45% of these structures had loose nuts for anchor rods. It created the concerns in the soundness of these structures that may affect the public's safety.
When a nut becomes loose, either through over-tightening or under-tightening, it is no longer able to carry and transfer loading. The stress that it would normally experience is redistributed to the remaining tight anchor rods. This additional stress may cause these nuts to become loose at a quicker rate. Within Minnesota, 9 out of the 10 districts have reported to have loose nuts on their structures, with some districts reporting to only have 10% of structures with loose nuts. The Metro, with approximately 2,000 signs in their district, has reported to have upwards of 45% of structures with loose nuts. Within the nation, 24 of 29 states who responded to a survey indicated that they also had loose nuts on their structures. The percentage of structures with loose nuts ranged from 1 to 90% of structures. Loose nuts are not only a safety issue, but put tremendous strain on maintenance crews.
Our MnDOT maintenance forces are tremendously strained when we have to go out and retighten these loose nuts, or worse yet, repair or replace the pole because of them. During routine maintenance and inspection of signal and lighting poles, we observed several issues, including leaning poles, cracked or split anchor rods, and thread damage due to rocking poles. Top and leveling nuts so loose that they can be turned by hand, and anchor rod connection components not in full contact with each other. In some cases, more commonly found in smaller anchor rod diameters such as in light poles, over-tightening during installation has caused the nuts to come loose.
Critical safety is one reason to take the new nut tightening procedure seriously, because when followed properly, they'll minimize the risk to the traveling public. When properly followed, the structure is more reliable from day one and has a cumulative benefit of avoiding costly maintenance repairs down the road across the broader population of these structures.
MnDOT sponsored one research project to find out what caused the loose nut and how to solve the problem. Based on the lab test and the analytical results, a new nut tightening procedure was developed. New procedures will need to use specified torques and turns of nuts in tables and charts, separated by different sizes and grades of anchor rods.
By informing both MnDOT personnel and contractors about the basics of anchor rod tightening, as well as the different phases of tightening, the proper pre-tension can be developed within anchor rod connections. When the correct tightening procedure is utilized, those issues related to loose nuts can be minimized, mitigating MnDOT maintenance team efforts as well as ensuring public safety. Thank you.